Hello, we are Jason, and
And I'm Joel.
for the final project of time series class, and we want to forecast domestic stock market using foreign country stock indices. We assume that the domestic stock index is highly correlated with foreign country stock indices due to the global corporate governance. Here we want to focus on the KOSPI index from South Korea and NASDAQ index from the United States. So we want to introduce our project online.
So once we had our data set cleaned up, we turned to variable selection. Now, for our study, we specifically wanted to look at the US NASDAQ, represented by IXIC, and the South Korean KOSPI, represented by KS11. Now, when we actually look at the data sets itself and we look at the opening values of the KOSPI or the NASDAQ, we see that in both cases we have wandering or potentially wandering non-stationary behavior. So we see that over time there is no clear trend within the realization. We see that within autocorrelation factors that each value is highly correlated with the value preceding it, and this correlation does not decrease over time. We see this in both KS11 and ICSIC. And then we also see from the frequency plots that there is a large peak at 0 hertz, and this is indicative of non-stationary behavior. This is something that's very common, and this can make it difficult for predictive models in time series to actually predict future values. So we have to be very selective with the models that we come up with.
Now I want to introduce our univariate model. Start with ARMA 6.4 model, and we did a young box test after visual inspection and suggest some signal is not captured by the model, and due to the limitation of the ARMA model, and like you see in the figure, the red line forecasts like almost straight line after the end of the data you want to forecast. And also the long-term square root ASE is 1581, and also short-term square root ASE is lower than long-term, like 225.
Our first VAR model sought to look at volume and opening data for the KOSPI and the NASDAQ indexes. Now, when we ran multivariate VAR using volume and opening data, we found that the short-term square-rooted ASEs were indeed larger than what we got from our univariate models in both short-term of 30 days and long-term of 365 days. It was a significant jump in ASE or square-rooted ASE value. But what we did notice is that the predicted values seemed to capture the downward trend associated with the end of our data set. Now, this suggests that our VAR model was actually able to some extent, predict the downward trend that we saw at the tail end of our data set. After we ran our VAR model, we next turned to neural networks. Now, here we had to get a little bit selective with how we ran these. When we tried to use any neural networks beyond just looking at opening data, we ended up getting models that would crash, or they would end up taking so long to process that we could never actually see their results. So for the time being, we only looked at a neural network looking at the NASDAQ opening data. Now, when we did this, we saw that the ASE was significantly larger than either the VAR model or the univariate model. Same with the long term. Now, this suggests that on its own, the opening data is not enough to create a robust neural network. Now, after we ran our neural network, we next moved on to ensembling. This is a technique that is traditionally used when you have several weak models and you hope to use them together in the hopes that they can produce a more robust prediction. For our purposes, we looked strictly at our two best performing models, the ARMA and the VAR, and we decided to use mean ensembling to get our ensemble predictions. There are other forms of ensembling, like stacked ensembling or median ensembling, but we did not look at those here. With the mean ensemble performance, we found that after bootstrapping the predicted values and comparing those to the actual, the average square rooted ASE for a 30-day period was about 366.5657, essentially saying that over a 30-day window, each prediction is off by about $366. Now, there is also a confidence interval associated with this, but these do suggest that the model is performing better than the VAR, but not the ARMA. So this suggests that perhaps in the future, if we can produce more robust models, perhaps we can produce better mean ensemble predictions.
And also, the long-term performance comparison is higher than short-term performance, like as expected.
Now, in conclusion of what we did from our models, we do see that there is evidence that predictive models are capable of not only tracking, but predicting ICSIC values, at least with the opening values. Now, we saw this with our VAR and our neural networks, where they were able to capture that downward trend or anticipate that downward trend that we saw at the end of our data set.
Yes, in the future projects, like Joel said, previous conclusion, we want to do bolster processing power. For example, using HPC, parallel computing resources from SMU. And also, please search TSWGE in Kaggle, and there is additional analysis and time series forecasting using VAR model, and also TSWG packages for like other countries like Korea and the United States and UK and Brazil and Israel. So please contact Joel and Jason if you have additional questions using this link and see the Kaggle pages. Thank you so much for your time.
Thank you.